All right, welcome to another Technical Days session with MCAD Technologies. Today we're going to be taking a look at advanced surfacing techniques. My name is Alex Horsfold, so let's get started. So first off, we're going to talk about some general approaches to working with surfaces. Essentially, surface bodies require many more features in order to get to the same result as a solid shape. And that's just because of the zero thickness nature of surface bodies. We'll also take a look at some sketch tips and tricks while working with splines. For the surface tools today, we're going to focus on lofts, boundaries, and fills. We'll talk about the similarities and differences between lofted and boundary surfaces, and then also fill surfaces, why we might want to use these in particular cases where they work best in. And then finally, as far as surface design goes, how we can use that to benefit us in top-down assembly modeling. So as a general approach to surfacing, like I mentioned, surfaces usually take many more features in order to complete the same kind of geometry that you would need for a solid surface or for a solid body. And essentially, whenever I create surfaces, I use very simple shapes, and I create something that gives me an overall curvature of the part that I'm looking for, and then I can trim later any details that aren't important to that particular body, or areas where I need to refine the detail, like in the case of this fender. Like I mentioned, you want to use simple shapes, so things like lines, arcs, and simple splines. You're going to want to use tangency and curvature to control how smooth the surface is as it leaves another face. So let's take a look at one of these examples here. So I'm going to switch back into SolidWorks, and let's take a look at that fender that I showed in the first image there. So I'm going to roll back to just before the surfaces there that make up that fender. Now here you can already see that I've trimmed out a section, and the reason I'm trimming this out is because this original feature was created with one singular lofted surface, which didn't capture all the detail that I needed in the headlight. So in order to fix this, I'm adding some complexity here with boundary and fill. Now the nice thing about boundary surfaces here is they give us a little bit more control and flexibility versus a loft. So you might be asking yourself, why wouldn't we use a loft here instead of a boundary? And the answer is, I wasn't exactly sure how I wanted these curves to blend from one section to the other. So it's a lot of guessing games and just taking a look at the resulting surfaces and finding something that's balanced that looks good. And again, you can see another boundary surface here where I wanted to be able to control the position of these endpoints on the boundary until I got a shape that was close to what I was looking for. Now we'll talk about some of the other options here in boundary surface as we compare them to lofts a little bit later. As we go farther down the tree, another feature that I wanted to take a look at here is a fill surface. Fill surfaces are great whenever you've got more than 4 edges or less than 4 edges, so 3 or 5 or more. And the reason being that it produces this mesh pattern over the surface, and you can also control the tangency at each edge. So things like just contact, tangency, or curvature continuous. Now you'll probably also notice too in the feature manager here that I've been separating features into folders, and the reason being I have a lot of information here. I have things in my datum folder like sketches that show the overall length of the overall layout of the part that I'm going to create. And like I mentioned in the beginning here, I started with one singular loft. That probably wasn't a good idea in the beginning, but it made sense when I started this. So all of the detail for that loft is mainly up here in this datums folder. So when we talk about splines, and by the way, this is a B-spline. So the idea here is which one is a better representation of the shape. And some will pick this side, the right-hand side, the one with the more points. Others will say that this is a better curve. And really the only way to check to see which one is better or not is by taking a look at something called curvature. This you can get to by right-clicking on a spline and show curvature. And the lines indicate the amount of radius or the amount of curvature in the spline at that point. So the smoother the spline, the more consistent and changing the radius is as it travels along the curve. So anytime you've got a large bump in this curvature cone, the rougher the surface is. It's not as smooth. Now, it may not be easy to see here, and you may say, well, what difference does that make? Well, if we look at the final result after we use that spline for something like a revolve or a loft, you'll start to notice some jaggedness in the surfaces. Now, both of these parts here, these are both in the same component. They're both using the same image quality for smoothness, and you can see that the one on the left is much smoother than the one on the right. And that's because it uses less control points. So let's talk about a couple of other things that we can do with splines. So first of all, a lot of users don't know that there's actually now two different types of splines in SolidWorks. Since 2014, SolidWorks added something called a style spline. So the normal splines that most people are used to since probably the beginning of SolidWorks is something called a B-spline, and that's where you add a series of control points and the spline actually intersects at each one of those control points. The second type of spline that you can create is something called a style spline, which is also known as a Bezier curve. And a Bezier curve is a different order of spline. Instead of adding a series of control points that the spline has to go through, you're instead creating a box that controls the direction of that spline. Now, there's not as much control that can be done with a style spline. You'll notice that there are no curvature handles at the ends of the spline. We can, however, add relationships to these lines. I could make this tangent to something or parallel. I can even add dimensions to these or angles to define this spline. But I don't have any control over these endpoints. Now, on a normal B-spline, we do have some control here. And here you can see that as I click on this spline, we get this box that pops up. This is called a control polygon. I can use this to control a series of points through that B-spline, or I can control individually the handles at each control point, so either at the ends or at points along the spline. Now this is all great and good to be able to control these points, but you're actually adding more complexity to the spline, and SolidWorks has to work just a little bit harder to control the calculation of the spline between segments. Whereas on a B-spline, the spline is controlled through each point, or through each series of points. So we've got 1, 2, 3 segments here. On a style spline or a Bezier curve, we have one complete segment. So these are much easier for SolidWorks to calculate. They're much easier to define, and they also lead themselves very well into symmetry. Now, I mentioned the curvature before. If you want to get to that, you can right-click and show curvature. If these handles don't automatically come up for you, you can right-click and display control polygon. And these are just toggles. You can toggle them on and off. Now, also in options, you can have these come on by default. So under Sketch here, we can show spline tangency and curvature handles, show spline control polygon by default. And I also like to have this one on, ghost image on drag. This gives me an idea of, as I modify the curve, I can see exactly where I left off. You'll also notice too that my curvature display is a different color, and these can all be adjusted through the color settings, or the system color settings in SolidWorks here. And specifically, you're going to want to change this temporary graphics, temporary graphics shaded color. You can change this to any color you like, and that will change the curvature. Another nice trick is sometimes you'll create a couple of splines and you realized you made a mistake. Maybe you need to add more control points, or you should have made it longer, but at that point you're kind of stuck with what you've got. Well, actually, splines can be joined together. So even though these two are not they're not tangent right now, they're not the same spline, we can actually join these into one. And we can do that by simply making the curves tangent, and then I can delete this control point that separates the two splines. So now it adds a control point, and it makes the spline one complete spline, and just adds the segments together. Now you can do something similar with lines. If I make these two lines collinear, I can also delete control points. Same thing with arcs. If I make two arcs co-radial, by the way, this does not work with concentric, so co-radial here, I can delete those control points. So again, keep it simple whenever you're working with splines. The less number of points you have, the smoother the curve is going to be, and the less overhead you'll have on the software. Use the curvature handles sparingly, because like I said, the overhead to SolidWorks, there's more math that has to be done to calculate the shape of that spline, and I've had mixed results when I'm modifying these curvature handles to an extent. So keep it simple as much as you can. Also, only add more points when you need to make subtle changes. So normally what I'll do is I'll just simply make 2 points on a spline. I'll adjust the tangency at both ends, and then I'll add more points to a B-spline as needed along the curve. Or I can use a style spline and simply add more points to that as well. Splines can also be simplified by deleting those control points in B-splines. Some other terminology here. So I mentioned those options. So I always like to have these turned on whenever I'm going to be working on a project with splines. And we've got curvature combs that we can show by right-click. Same thing with control polygons. We can turn those on and off. And like I said, keep it simple. You can create the same basic shape with less points. It's less overhead on the software, and you're going to get a smoother spline in the end. All right, so now let's talk about some of these other surface tools. So let's take a look at a loft. So what's the difference between a loft and a boundary? Well, there's not a lot that's different, but each one has its own benefits. One good benefit to a loft is the ability to use a center line. So this is very similar to a sweep in that you have a profile and a path, but you can also control with just profile sections at the beginning and the ends of the curve. So let's take a look at that. All right, so let's talk about some of the unique abilities of a loft. So like I mentioned, lofts have a unique ability to add a center line. These are very similar to sweeps, but you can instead have two profiles at the beginning and end of the curve. And then using this center line parameter, you can have the loft follow along that shape. Another difference with the loft is we don't have a whole lot of controls at the ends of the lofted shape. We do have the ability to control the direction, but like I showed earlier with the boundary curve, I can control the endpoints at each profile. With a loft, I can only control the direction. We also have controls like start and end constraints. So if I wanted this to be tangent to a surface as it left the edge, and this twist will actually propagate itself around. So how would we want to combat something like that? So the answer would be to break up these edges. So right now these are two complete curves. I would have to separate those edges into two different segments using something like a split line. So a split line simply takes a line, projects it across the surface, and breaks it into two halves. So now I have two edges on the upper and lower surfaces. From here I can loft from one edge to the other, but I can only select one edge of a profile at a time. So to help me with this, we have something called a selection manager. And you can get to this by right-clicking either in the profile window or in open space. From here, this gives me the ability to select a loop or closed group. So I can easily select a couple of edges, add that as the group, and that becomes the profile. And now, notice that my guideline is perfectly lined up to the edges. As you move it though, there's no way to get that to pop back without just resetting. So I could reset all these connectors. And again, just like before, we have the ability to control tangency at each face. Tangency also has the ability to be a weighted amount. So notice that as I increase this weighted amount, that the sections or pieces of the mesh there that we can see in detail, they get farther and farther apart. As they meet up in the center, they get closer and closer together. So again, center line and guide curves, those are the two main advantages of a loft. We also have the ability to control the end conditions. So the default for 3 or more profiles is a parabolic curve between the sections. We can also control at the start and end the type of continuity. So none meaning contact or C0. We also have the ability to control if it was a sketch plane, whether it's normal to that profile. This works great for symmetry. We can also just draw a line at any direction and use that as a vector for determining the tangency. And we can also control C1 and C2 curvature or continuity for tangent and curvature. So boundary surfaces, what's the difference here? And like I mentioned before, boundary surfaces have a unique ability to pull these endpoints away and adjust the shape of the surface. But there's some other tricks here that I wanted to show. So when we're editing this boundary surface, so each curve, and you can see the layout here is a little bit different than a loft, where you have to actually be selected on the curve that you want to control here. So I can control, again, curvature, tangency, or just contact. But it also has the ability to align the profile or align the surface with geometry that it's connected to. So we can align this to the edges of the part. And you can see how that affects the outer edge there. We also have the ability to control the direction using the underlying geometry of the surface that it connects to. So not just tangency, but also aligning with the direction that curve started from. So for example, this edge here, if we were to align this to something called an isoparameter, you can see that the direction of this curve changes drastically. And depending on where I place these endpoints, it's going to align itself to geometry slightly differently. So what is this being aligned to? Now this geometry we typically cannot see, but we do have a sketch tool that we can use to look at this. So we have something called a face curve. Face curves will allow us to look at that underlying geometry and figure out exactly which direction that goes. So here you can see that these lateral lines, they're kind of following this lower curve, and this is all based on the way that this first surface was created. And you can see that the boundary is aligning the direction to those normals, or those isoparameters in the underlying surface. Now boundary surfaces also have a unique ability to only need to use one profile for a direction. So if I just make a simple spline here, and we'll go 90 degrees to that for the second profile, and we're not going to even place it at an endpoint. We're just going to put it somewhere in the middle. So I'm just going to make sure that these two intersect. I'm going to use a pierce constraint. Pierce is a great way to find an intersection through the sketch. And I can use these two curves for boundary. So one curve for one direction, one curve for the other direction. So next let's talk about fill surface. Again, fill surfaces work great for 3-edged holes or 5 edges or more, and that's because this is also called an end-sided patch. You can have as many edges as you want, and you can control the curvature or tangency at each edge. It also prevents the bunching of ISO parameters in the corners. Now, what do I mean by ISO parameters? Let's take a look at this in SolidWorks. So here on the Corrado model, I do have a surface fill here, but let's take a look at maybe another method that we might use to finish off this area. So one way that you might finish this off is to maybe loft a shape here from this edge to this edge, and then from that resulting curve you would be able to finish this off with a boundary or a loft or something like that. But what happens is, if we use a loft here, in this lower corner, all of these points terminate into a singular point. This is very bad because the software does not know how to go to infinity here. It goes down to a singular point. That this can have all sorts of problems with other features, with things like fillets, or just trying to clean up the geometry here, and it just doesn't look nice. And we can see that here. If I make these tangent at both ends, that we always have this kind of black hole in the corner here. Everything seems to kind of terminate in this corner. So a better solution would be to use a fill surface. Now all of these adjacent surfaces they're already knitted together. So an easy way to select all of these edges is to just right click and select open loop. So there you can see it does select all of the edges individually, and if you know in the beginning here that all of these edges need to be tangent, you don't want to set this first. So if I clear this out and then set this to tangent, I can control each one of these as tangent as they get selected. And then I can go back through each edge and redefine exactly how that tangency works. So for example, maybe this edge here, I can find it in the list. So this one here, we would want this to be contact. And then just moving our way around. So these edges here, we would also want contact. We don't want these tangent here. We just want them to be touching or intersecting. So there you can see we remain tangent to the outside surfaces and just touching on the inside faces. And so the result is a very clean surface with not a whole lot of extra work. So again, with the fill surface command, this works great for 3-edged holes, and it also helps to prevent the bunching up in the corners using a loft. And then also remember too that tangency can be controlled at each edge. And last, this is a new feature for 2015 where you can now visualize the mesh and the curvature to make sure that you've got the right shape before you hit that OK button. So the last thing we want to cover today is top-down assembly modeling using surface bodies. And the basic gist of this is that I can use each individual body from my model, from my what we might call the base part, to export those into their own individual components so that I can continue with the design. So this helps create models that are both detailed with low overhead, and if I need to modify the original shape, I have one part that I do that in, and it's going to update a family of components below that. So let's take a look at how we might do something like that. So coming back into SolidWorks here with our Corrado model, right here from either the solid bodies or the surface bodies folders, these surfaces can be exported. Now I can do them all at once. So if I right click, insert into a new part file, I can insert all of the bodies into one complete part, or I can select individual surfaces. So for example, if I just want the side windows in their own component, I can pre-select those two bodies and then save this into its own file. So by doing that, SolidWorks creates a parametric link back to those surfaces. So if those two original bodies ever change, then this model will also update. All right, so what did we learn today? So again, the general approach to working with surfaces is you want to keep it pretty simple in the beginning. Remember that the surfaces normally or should be bigger than the geometry that you need, because you can always trim that away. You can also trim out specific areas that you need a little bit more detail, as we demonstrated with that fender earlier. Whatever you're working with splines, again, simple is more. The less detail points that you have, the smoother the curve is going to be. And remember, we now have two different curve types in SolidWorks. We have the original B-spline, but we now have that new Bezier curve. And then the difference between lofts and boundaries: lofts have a unique centerline ability, but they lack the control at the endpoints and the ability to control the geometry from the surfaces around it. And then for filled surfaces, in those areas where you've got an odd number of edges, either 3 or 5 or more, fill surface works great because you can still control the continuity at the edges of the body. And then finally, we learned with top-down design that starting from one part model, surfaces can be broken down into their own individual bodies, and more detail can be added. If you'd like to download either of these two models, I have these available on grabcad.com, and they're listed as the Corrado SLC and the Porsche 356.